Hello, students! Today we're going to discuss the metric system, or the international system, or it's called the SI system. I know SI units. I know you've heard that before. It actually stands for Système International, to be really fancy about it. That's what SI means, and there are, for each quantity, official scientific ways to measure them, and units to use. So for mass, we use the base of the kilogram, or kg. Length is meter, or m. Lowercase m, pay attention to that. Time is seconds, or s. And temperature is Kelvin, sometimes centigrade or Celsius, but Kelvin is an actual measurement of movement, so this is why Kelvin is most commonly used. Common prefixes to use and to know are listed here, and the ones you really want you to know are the ones with the asterisk, and you should know most of them, but perhaps you don't know a couple of them. Mega is new, probably to you. Maybe you've heard of megabytes. That's actually a million bytes, MB. Kilo, you've heard of probably before. The kilogram has the K prefix to it, and that means 1,000 of something. So a kilogram is 1,000 grams. And then the base are the typical units. That's grams, liters, meters. You could even have seconds be your base. A lot of bases, bytes, like I talked about before. Could be, these are the typical ones that we're going to use. But again, that's the base unit, and that's just 1, or 10 to the first. Deci we don't use too often. Centi, I definitely want you to know. That's 1/100th of something. So each gram has, or each meter has 100 centimeters in it. And then milli is 1/1000th, or 10 times 10, or 1 times 10 times the negative 3 times 10 to the negative third is 1,000. So m, notice this is also lowercase m, so millimeters would be millimeters. Nano we might use, micro you use in microscopics, pico even sometimes is used in biology, but this is all I really want you guys to know. Remember, you're going to memorize the asterisk ones. And now let's talk about dimensional analysis, which I think if you leave from chemistry with one skill, this is absolutely the one that I want you to use. I used it in my lab all the time. It's very helpful, and I think maybe it could even change your life. And we're going to use metrics to explain how to do it, and then we're going to do it again when we get to other types of conversions. It's great, trust me. Sometimes it's also called the factor label system, or unit conversions. This is how I learned it, but dimensional analysis works great. And it's used to convert from one measure or unit to another using known conversion factors. So, the way it works, say I wanted to convert from 4.5 kilograms to grams, and you don't want to write out the stair steps. You don't need to worry about the stair steps anymore if you can remember what I told you to on the last page, and this, you're going to be able to solve all problems in the future. So first, you copy down the number and the units, paying attention to sig figs. Yep, they're not going away. Then you're going to use factors to cancel units and generate new units. These will be the new units, and these will be the ones that you cancel. And then you repeat as necessary, and then you just plug and chug. You do the math. Let's do an example. So if I wanted to go from 0.851 grams to milligrams, this is what I would do. Write down step 1. Write down the number and the unit. Now, we want to get to milligrams, so we need to get rid of the grams. So, that means, because we want to go from grams to milligrams. So step 1, write down the unit. Step 2, write down the unit you're trying to get into. In this case, milligrams. Then, we could draw this little T-chart here, which is going to help us set things up and organize things. We get our equals, and now we do a conversion factor. So we know that 1 gram equals 1,000 milligrams. We've memorized that. And this works out well because we want to cancel units. We basically want to turn this into 1, because if I have 4 divided by 4, that equals 1. If I have anything, if I had this symbol over this symbol, pretend it's exactly the same, that also equals 1. It's the same thing over the same thing equals 1. So grams over grams cancels out, leaving us with the units that we want. So we know we're sitting pretty. Like I said, grams are out. We multiply the math, or do the math. 0.851 times 1,000 divided by 1 equals 851. And this seems like a lot of work, but you're going to need to use this skill quite a bit in the future, so get good at it now. Let's do another example. Let's go 342, or 34.2 centimeters to meters. So first step again, we're going to write down our number, 34.2 centimeters. We're going to write down the unit that we want to get into, meters. We're going to draw our T, so we can cancel our units. And this basically just means, this T just means this times this divided by this. So that's really what this means. It's just shorthand to show that. But 34.2 centimeters times some conversion factor gets us into meters. And again, we want meters on top, so we're going to want meters up here. And we want centimeters down here, because like I said, I want us to cancel out. So we know 1 meter is 100 centimeters. 1 meter is 100 centimeters. This is great because our units are going to cancel. Centimeters cancel out. That equals 1. So then we do the math. 34.2 times 1, then divided by 100 will give us our answer of 0.342. 0.342. All right. And then now let's go 23.2 kilograms to milligrams. Let's see if you can figure it out. Try to do that yourself. Okay. Yep, first step, 23.2 kilograms. Second step, we're trying to get to milligrams. Yep, and then we set up our T. We know we want milligrams up top over here. Milligrams. We want to get rid of kilograms. In fact, what we're going to do is, this is typically this is going to be a two-step, because we want milligrams here, but I don't know how many kilograms. Well, I do, but maybe you don't know how many kilograms or how many milligrams are in kilograms, so you can do it a two-step problem. So you go kilograms, 1,000 grams is 1 kilogram. Okay, that's going to get rid of this unit, but are we in milligrams yet? Nope. But we do know, since we memorized, that there are 1,000 milligrams in 1 gram. So we do another one. 1,000 milligrams in 1 gram. Ooh, these units now cancel. Oops. This is going to cancel. This is going to cancel. And now it's just math. It's just 23.2 times 1,000 times 1,000, all divided by 1, because we only have 1 here, so we don't have anything to do here. So we know our answer is 232 200,000, or 23,200,000 milligrams in 23.2 kilograms. Two-step conversions, you're doing exactly the same thing. You just want to get rid of units until you get your final unit. So I'm going to have you guys convert these. We'll see how you do. And yeah, I hope you learned this. We're going to practice this a lot, and I hope this was helpful.